Okay, I think we'll get started. This is the IETF 109 meeting of the Web Transport Working Group. A few meeting tips.
Good morning, afternoon, all the time, everyone. Actually, Bernard, if you want to enable video as we're going through the chair slides so people can see how personable and nice we are.
Or how sleepy. Let me see here. I'll enable video. Okay, and go back to slides. So the session is being recorded, and if you're here, you're automatically in the blue sheets. Please join the session Jabber room and use headphones, although I'm not doing that. I'm using an echo canceling speakerphone. And state your full name before speaking so we can get you into the minutes. David, do you want to give a few tips?
So the Meet Echo tool makes sense, but it's not necessarily very intuitive. So you need to do separate things. Like if you want to speak, you need to first enter the queue, and then like the chairs will call on you at some point. You'll have to manually leave the queue yourself when you're done speaking. But also, once we call on you, we'll just say something. We don't have a button to press to let you in like last time. So you need to yourself enable your audio by unmuting. So that's the button here. And then when you're done, you like kind of stop by saying you're done, and then you mute, and we'll move on to the next person. We encourage folks to use their camera if they're comfortable. It's a lot easier to understand each other, especially across like different accents and everything, when you can kind of see the person you're talking to, but that's not a requirement by any means. So
also, you need to leave the queue yourself. If you don't actually press the tool to leave it, you'll stay in it. Okay, then note well. Just a reminder of IETF policies. You've probably heard this several times already if you've been attending other meetings. And by participating, you agree to follow IETF processes and policies. And definitive information is in the document listed below and other BCPs. If you want more info, please talk to the working group chairs or the IDs. So at this meeting, the agenda is posted and it's up to date. We will want a volunteer for note taker. I believe we have a volunteer for Jabber Scribe, but we will want somebody to take notes. We have the CodeMD at this link, so it's easy to do, but we do need a volunteer so we can keep notes for what is about to transpire. Do we have a volunteer? I'm not
until we have someone who can help take notes. It's really not that much work, and there's really no pressure. We're not expecting the notes to be perfect.
Right.
Like it's just a helping hand.
So we can fill it in, but
yeah.
I'm assuming that maybe everyone is clamoring to volunteer for note taking, but they haven't figured out how to use the audio tool.
Looking for the link so that we can verify we can actually get into the notes this time.
Yes, please.
So from Meet Echo, if you click in the top right, there's a link to the note meeting tool, and you can either have it inline or you can open another tab.
Yeah, if it's working the way we think it is, you should see the agenda in the tool when you open it. Or at least that's what I think I put there.
Okay, I can do that.
Thank you so much, Mike. We really appreciate it.
We really do. Okay. So here is the agenda. We have the preliminaries, which you've just talked about. We should probably do the agenda dash as well. David will handle the queue. And then we're going to have Will Law from the W3C Web Transport Working Group to give us a little update. Luke will give us some developer feedback from the Web Transport Origin trial. Then we'll have Victor do the overview and requirements. Eric will do HTTP2, and then Victor will do the quick and HTTP3 drafts, and then we'll have the wrap up and hopefully a bunch of time for discussion during this session. Is there anybody who'd like to bash the agenda or have another suggestion? Okay, so we'd like to turn over the floor to Will Law. Are you there, Will? Will, you need to, if you're there, you need to press the audio tool to unmute yourself.
Not seeing him in the currently present participant list.
Okay, well, I can give his slide probably well enough for now. So I will do it. The W3C Web Transport Working Group has been established and the charter has been published. And the working group's been created and all that. They did hold meetings during the W3C TPAC, held two 2-hour meetings. And now they have set up bi-weekly meetings at an alternating time slot of 7 a.m. or 4 p.m. Pacific. And it's all on the W3C Web Transport Wiki. So you can go and find out all about it. We have some draft editors. And there's been a call for consensus to adopt the existing Web Transport API spec. And so it's now in the W3C Web Transport GitHub. So you can look for it there. There are lots of issues that have been filed by various people, including folks that are part of this meeting. And so work is underway. And if you're interested, please participate. All right, so now we're going to have some developer feedback. Luke will tell us a little bit about what he's experienced. I also have a few observations to make. So Luke, I'd like to hand the floor to you.
Hello, everyone. I'm Luke. I am a software engineer at Twitch and also Amazon. We were purchased a while ago and always forget about that. Yeah, we've been messing around with web transport quite a bit and have some things I want to just talk about.
Yeah, so just to be clear for everybody, Luke's going to be giving feedback on the Web Transport Origin trial. Here's some basic info about it. Basically, if you've got Chrome or Edge up to M88, like the Canary, you can play with it. You should probably, I guess, do, for the latest API, if you're just working from the API draft, I guess M87 or later is a good thing. And there's some various info on the web to get more experience with the API. But go ahead, Luke.
Yeah, so to that extent as well, there's a few hurdles to get the API going, but the stream part of the API, quick transport, works somewhat well. I'll go into some of the specific bugs, and the datagram component works as well. And you have to do stuff with self-signed certs. But there's guides out there, which is great. So yeah, just some heads up why we're trying to use quick transport. The first problem we're trying to deal with is head-of-line blocking. Surprise, surprise, it's kind of why Quick was designed to power HTTP3. Because as we've noticed, when you deliver a lot of media, it's usually sequential. You know, like we're streaming this video call, or you'd be watching a video download. And anytime you have congestion, it just causes the queue to back up. Either when you're contributing to a website, like you're creating a stream. We use RTMP at Twitch, and congestion causes back pressure, which increases latency. And then on my half, I work on the distribution team, like the CDN team. We run our own low latency live video CDN. And again, if anytime your network sputters just a little bit, it causes a roadblock, increases latency. So we really want to use Quick more than anything to investigate how to solve this, and this has some interesting like ramifications with yeah, how to do it. So next slide. The crux of our idea on how to do low latency video is that we really want to break video into components such that if there is congestion, they're independent of each other. So we want multiplexing. We want to have multiple requests in flight. And I think more critically, we want to prioritize such that if there is congestion, we make sure the important data gets there first. So we're using quick transport. I went through and wrote my own quick implementation because we're a Go shop and the existing quick wasn't there. And yeah, we're right now running experiments for employees using the Origin trial, and we want to try to hit some production traffic early next year to try and see how it works. Next slide. One thing we've had a large debate over is why not HTTP3. It's really because low latency is hard to do, especially over such long stateful connections. You have to go into the area of like HTTP push, and you have to start mapping, well, I'm going to have to make the client do these requests in this order, this frequency. And it also gets difficult when you want to try and have the same API for contributing and distributing video. You have to deal with firewalls. So if the client is pushing video, it's a different API than if the client's downloading video. So it's really nice to have like a quick-based API where it's just arbitrary streams. It doesn't matter who initiates, doesn't matter who's receiving. The API is symmetric in that regard. And quick transport is so simple. We don't need connection pooling like HTTP3 transport. There's almost no point having fallback HTTP2 transport support because we just don't want it to work with TCP. We want to use quick. And also it's nice that datagrams are a potential fallback. So this is, if we do run into issues with, let's just say, the quick implementation, it's always nice knowing that you have this like Swiss Army knife of being able to do it yourself. So next slide. I've gone through and filed quite a few bugs with the Chrome implementation, which is great. More or less the state machine just needed some to be able to handle a few cases better. A lot of stuff where really the only case that worked out of the box was if was remote initiated unidirectional streams worked great. Otherwise, there's always like little subtle issues with every other configuration. So here's just a few tickets if you want to go through. I think most of them are being worked on. Some of them are fixed. I know using the entire CPU core is fixed. And that was just a busy loop in the kind of like the wake up logic. But we run into a few things like half closed streams, for example. Should the Web Transport API require half closed, or should it just be vague, or does it defer to quick? Just a few things that needed like the draft to mention it explicitly so that implementations don't miss it. Let's see, and then final slide. So quick transport's working great for us for distribution purposes. We're thinking about using it for contribution, but there's a few things we would need out of the Streams API. And so this is a little like feature bucket list at the very end. But prioritization, we're really concerned about congestion control, and I know it's very hard to do like a way to pick things out. And some issues with datagrams, like if you try and send a high rate of datagrams, you run into fighting with the underlying congestion control mechanism that you also don't have control over. But yeah, that's it. I think I've given more fine, detailed feedback by posting issues. at least on GitHub. And yeah, if anybody has any specific questions as well about what the origin trials are like, but it's been great so far. Just being able to run quick transport in the browser, it's been a lifesaver. Even before H3 support is ready.
Okay, thank you, Luke. I just wanted to give a little bit of feedback. This is the requirements and use cases that the W3C is developing. I'm not going to talk about all of these, but just make an observation about a few of these use cases. In particular, I wanted to talk a little bit about low latency streaming use cases, such as game streaming and remote desktop, and then a few what I would call large-scale events use cases. These are for a lot of participants, like at least 10,000. Things like company meetings or concerts, political gatherings, sporting events, stuff like this. The distinction between these two is the large-scale events generally don't have the same tight latency requirements. So for many of these things, like a second delay is okay, whereas the low latency, it needs as low latency as possible, because you're talking about things that could be disrupted by additional latency. So a little bit on the low latency streaming use cases, and the primary ones, I work with a lot of developers in the gaming and remote desktop cases. They are almost always focused on quick transport. That's the thing that they ask me about and they want to learn more about, so they were using, a bunch of them were looking at the Origin trial. One thing I think it's important to understand, and this is true of any use case, is to understand whether it's a greenfield use case, whether people have something they're already doing it with. And then if they do, you have to understand what the bar is to get them to move from whatever they're doing now to what you want them to move to. So in this particular case, for these things, we see the developers are using today WebRTC, the data channel with RTP audio video. So in the case of the remote desktop, typically the audio video, they'll use WebRTC screen sharing, and then the data channel for the keyboard and mouse events and control. For gaming, we see client server game streaming, which is done exclusively with the data channel. So they send the audio video and the control traffic, the keyboard, mouse stuff over the data channel. We've also seen gaming done with RTP audio and video as well, with the data channel being used for the keyboard and mouse as well. And I would mention that there's a number of developers who use both client-server and peer-to-peer use cases. So for example, you could stream a game from the cloud, but you could also stream it from your game console to a mobile device. Or the remote desktop could be a remote desktop in the cloud, or you could be just doing a remote desktop with your own desktop, for example, as well. So a bunch of these developers, they're supporting both client-server and peer-to-peer, and they like to have a single code base. They don't want to have to write a completely different implementation for peer-to-peer versus client-server. And that's one of the reasons they like WebRTC, is because it kind of gives them both. And yes, for the client-server case, they need ICE, but it's more important to them in general to have the ability to write one code base than it is to get rid of ICE. So I know we pitched one of the things about web transport is we get rid of ICE, and the answer from a bunch of these developers is, I'll keep the ICE if I can do the peer-to-peer. So a lot of these folks have a strong interest in the peer-to-peer extensions of web transport as well. A few other things, some of these applications are pretty high performance, like the game streaming. And what I mean by this is that the streams themselves may not be huge in terms of bandwidth, but often the things that you're streaming to are not very high performance. So it can be, for example, an older game console or something that's not very powerful. So some of these folks were having issues with the data channel because the way that JavaScript back pressure is implemented in data channel. So offering them potentially better back pressure was a very attractive aspect of web transport. But as Luke just mentioned, it's not for web transport. reliable web transport, it does solve a lot of the back pressure problems kind of nicely. So you don't have to have, basically what we saw with the data channels, they were doing a lot of application layer acknowledgement. But for datagrams, you still need the app layer acknowledgement. So in some ways, if for developers who are using datagrams in this scenario, they're not seeing a lower level of complexity with web transport. And they were kind of hoping that web transport would allow them to get rid of the application layer hacking that they were doing to make the data channel function. But they're not seeing that advantage. They still have to do their application layer hacking. The other thing is that they were asking about just some basic DevOps issues. Like, for example, say they bring down a gaming server. Is there a way to migrate these web transport connections to another server? So there's just some practical aspects of the clustering and draining that they wanted to understand how to do better. I've also heard the bandwidth allocation. It's a little bit different maybe than Luke's prioritization, but they wanted to be able to allocate bandwidth between the datagram flows and the streams. And the reason is that the datagram is used for control traffic, so they don't want to be choked off. And they don't want like the audio video to take so much of the bandwidth that the control traffic, for example, experiences delays. So that's the kind of thing. I don't think they cared about priority in the sense of DSCP or anything like that, but just making sure that their control traffic had a certain minimum bandwidth. Okay, a little bit on the event streaming. This use case, there was more interest in HTTP3 transport. As I mentioned, the other one was quick transport. And the folks I've talked to here, the existing solution is HLS. So that's what they consider to be the incumbent. You would hear a lot because HLS is a pretty mature technology. A lot of great support in cloud infrastructure and CDNs, stuff like this. So here they had a concern about whether they could get the same level of ecosystem support for HTTP3 transport they could get with HLS. So a couple of things is they wanted to know whether we supported on mobile platforms, like, will I be able to get this on all of my mobile operating systems? Also, would it be widely supported in browsers? Of course, some of these questions I can't really answer right now, but they were a little bit concerned about the complexity of the protocol and pooling issues with HTTP3 and whether it would interoperate. And I'll talk a little bit more about that. But quick transport didn't worry them at all because for the other cases, because it's so simple, it's like, yeah, we think this will very likely interoperate and be the kind of thing people could implement widely. But HTTP3, they weren't so sure. And then they went looking, talking to their server vendors, and they got some disturbing feedback, which is that most of the HTTP3 server vendors were not planning to implement HTTP3 transport. So that kind of meant if they were using a stock kind of a server, they would have to implement their own combination of HTTP3 and the HTTP3 transport, probably within a framework. And then for the folks who were using Node, they discovered, oops, there's no quick module that's going to be available in any reasonable amount of time due to, I guess, some blocking issues with OpenSSL. And so they're kind of stuck with Python and AIO Quick. And for the people who are comfortable with Python, that wasn't a really big deal, but if they weren't, it was. And then they would ask questions like, will HTTP3 transport be supported widely by CDNs? Hard to answer that. And then there was a few folks doing this event streaming for like company events who were interested in enterprise. And this got interesting because a lot of these enterprises, they think of HTTP as the thing they use as a transport of last resort. So, a lot of enterprises, they block UDP traffic. They don't even necessarily allow TCP on all ports. And the problem is, in these kind of an enterprise, it's likely that Quick wouldn't work. And so we talked a little bit and said, well, we can do this HTTP2 failover. And the problem there was that if you're an enterprise that doesn't allow, that's that tightly controlled, you probably don't support HTTP2 either. So it wasn't clear that HTTP2 transport would really help them much, that this would help them with this enterprise problem. Things are very different from the folks who are more on the consumer side because they don't encounter a lot of these crazy firewalls. But this was just something out there. So a bunch of questions among the customer base about HTTP3 transport and how how much take up it would get in the ecosystem, and also interoperability due to complexity. Okay. Are there any questions about this feedback?
Before we jump to the next session, let's drain the queue. So I have, speaking not as, well, as chair, I will say, one of our main goals for this session today, oh, sorry, I forgot to enable the camera. There we go. One of our main goals for the session today is kind of getting out of the transport zoo, as we've been calling it, making some decisions in terms of all the possible transports we have, which ones we want to actually like focus on and which ones we want to like work on. But with all my chair hat on, I have some clarification questions for Luke. Yeah, perfect, cool. So the first one, you mentioned that you weren't interested in an H2 fallback. So just out of curiosity, if on a network that blocks UDP and QUIC, what would you use instead? Or would you just say my feature doesn't work, and that's also a reasonable option? I'm just curious.
Yeah, so we use HLS for distribution, and we would fall back to HLS as well for third-party CDN support if our first-party CDN is overwhelmed. So we're mostly looking for QUIC as kind of a extra functionality, and if it doesn't work, we'll just fall back to the the backup. That being said, like we could technically do our approach with TCP, but you just have fighting TCP flows and requests, so it's just easier to require QUIC.
Well, but I guess just my question is, if QUIC isn't there, you need something. You can't require QUIC because some users don't have access to it, and so then it's either you have a fallback inside, underneath the JavaScript layer, like that could be H2 transport, or you manually at your layer fall back to something else like HLS. I think they're both reasonable options. I'm just.
If we did H2 transport, I think the performance would actually be worse than falling back to a different protocol. Based on the way we're prioritizing data, because we expect the prioritization to take effect, but if under the hood we're using TCP, and the kernel doesn't prioritize, we're just going to have more buffering.
That's
it's a little hard to explain, but
yeah, I heard that same approach, David, which is that they would just fall back to HLS.
Yeah, no, I think especially for use cases that are already on the market or in production today, with something, it's natural to fall back to what they already have built today. Right. That makes sense. Right. Cool, thanks. And then I had a second question for you, Luke, which was, you mentioned quick transport and preferring that to H3 transport. One of the main questions we're trying to answer today is, do we want to build one of them? Do we want to build both of them? Do we want to build neither? I'm guessing it's not going to be the neither, but in your case, it sounds like you prefer quick transport. If the working group were to decide to reach consensus that we only wanted to build H3 transport, what would be your main objection? I think you're still muted. Oh, go ahead.
So on the mailing list, I've left some feedback, but it's really just H3 transport is more complicated to implement. In our case, no benefit because our web server doesn't handle H3 requests. It would only create this web transport connection. So it kind of seems redundant to also add H3 support. My implementation doesn't even support H3. So it's more like, is the complexity worth it? And for us, it's like, no.
Okay, so from your perspective, if I'm understanding correctly, you're building your own stack from scratch, and in that scenario, having to also build H3 is more work for limited benefit. If you're not, the main value add would be pooling, and if you're not using it, you're having more complexity with no benefit. Cool, thanks. That makes sense. And
yeah, also David, for the low latency streaming cases, they like the quick transport because they could conceivably get the peer-to-peer without building an HTTP3 server into their browser or their backend. So that's why they like the quick transport for those. Anyone else in the queue? Okay, I think, Victor, you're up.
Okay. So I have my main question, I guess, is so do I understand correctly that you serve directly video from? There is no reverse proxy or any other intermediation in your use case, because one of the reasons people are interested in HTTP-free transport is so for things like priorities, you can set priorities on your socket, but if you have priorities that need to cross a reverse proxy, you would have to communicate that, and HTTP provides that way. So if you're if you do not have any form of reverse proxy in form of your video server, I guess you're not interested. That's why I'm asking.
So we would use any form of H3 prioritization as an alternative. But yeah, we right now have we assign users to a host directly. If you go to Twitch and look at the network tab, you'll see when you start a video session, you're assigned to a specific host name, and that host is then able to prioritize traffic.
Okay,
if
and there is
video from 2 hosts, then we couldn't do it.
okay, and there is no direct. It's a direct connection to the quick server in question.
Yep. Yeah, we don't have any load balancers. We pushed a little too much data to have load balancers. We have an application load balancing tier, kind of like out of band.
Sorry, everyone. The chair's completely messed up the queue management here. So hold on there, Bernard. Let me handle the queue. And so we have 5 more people in it. Well, actually 4. Ian Sweat, you're next.
Cool. Thank you, David. So just FYI, I think that it's very likely that BBR2 would become the default congestion control in Quick at the end of Q1 2021. Is very close to done after a lot of work. So I think I am fairly optimistic about that. I do think that is a much better congestion controller than either BBR1 or Cubic for, yes, sorry, Victor clarified. Yes, in the Google Quick / Chromium implementation, I cannot guarantee it for anyone else, obviously. But you know, if you wanted to, you can just like yank whatever we have at the end of Q1. I highly support the direction of making a decision on these transports because I think moving forward is important. On the fallback issue, based on my discussions with YouTube, they also do not need a fallback to TCP because if they were to have a fallback, they would actually prefer to use HTTP 1.1 in their current solution. And although that being said, as long as they can say, I only want to use quick transport if I actually get quick transport, I think they would be happy to use quick transport. So it's not that they're, because they're importing our stack anyway, the cost of the implementation cost is low, but they would definitely not want to fall back to H2 transport. They would only want to fall back to H1. So as long as that functionality is preserved, then I think we're all good. Thanks.
Lucas.
Hello, can you hear me?
Yes.
Great. Thanks for the presentation, Luke. It was good to see some more detail on some of the stuff you've been working on. I've been following some of the issues. Some of those I experienced myself. So I was playing with web transport. I basically borrowed heavily from Google's example client code, but then wrote my own web transport server on top of Quiche. And that was really an experiment to see for an existing stack how much work it would. So that obviously leverages datagram. And so when I started this work, some of that was changes to the library to support datagram. And I kind of expected web transport might take some changes to the library too, but in the end, it didn't. I was able to just modify our example client and server to speak quick transport, let's say it that way. And that was quite low impact. I suspect for me, like adding HB3 transport to that toy server would have been quite simple too, because all the existing HTTP3 heavy lifting would have been there. But then, like, the fact I didn't do that is maybe telling that it's kind of a bit superfluous. Again, I didn't need connection pooling in this toy example. All I was doing was echoing something back. It's not as complicated as video streaming or anything, but you can see how somebody who's coming kind of new into Quick would want to do the easiest thing in some respect. So yeah, I think some of the questions I had have been answered in terms of, Luke, the kind of what work did it take on the server side for you to implement this stuff. But it seems that you're quite targeted towards this use case. So I think I already got the answer there. So yeah, just cheers for sharing. And I do agree that it would be good for us to come to some answer on what people want from either quick transport or HTTP3 transport, and how the fallbacks all relate.
And you absolutely need to tell me where I can buy that hat. Eric Kinnear.
Really nice to have some more concrete uses of, here's what I'm actually doing and how I need to send it and what that means. A couple of questions I had. I think datagrams do have congestion control, and you kind of spoke to that in contrast to the slides. And it seemed as though the not having control over that, I don't want to say that's a feature and not a bug, but I thought one of the benefits that people had been talking about previously, and it'd be really interesting to see if this holds up in practice or if it actually turns out that it's more annoying than it is helpful, is being able to share that congestion control context with the other data that you're potentially sending to that same endpoint, under the idea that much of that data is almost certainly taking the same, if not a very similar route, and therefore a congestion controller that can appropriately manage the amount of data that you're shoving through that pipe is going to be happier than many instances of congestion controllers that are trying to achieve an equilibrium. So it'd be really interesting to see if we can find any data about that, or if it's just, hey, I've got a congestion controller built into my thing right now, and so it's annoying to have this mode where it's not there. The only other thought that kind of comes with that is about the application layer acts. I think folks were mentioning in the chat that it's, in theory, if you had an API, the datagrams are ACT. And so if you had an API that exposed that to you, you wouldn't need application layer acts anymore. And from that perspective, if you're doing your own quick implementation, that seems a lot harder to me than either using someone else's quick or H3 implementation. But that might be one of those cases where if you needed those acts to be available and no implementation did it, that could drive you to doing a lot more work. So I think if we can get a clearer picture on the actual places that we need certain features, I think we have a long list of pros and cons of each side, and we need to kind of figure out which ones actually matter and which ones we don't care about.
We haven't gone down this route, but one of the problems with the congestion control with datagrams is that you don't know when the packet's going to be dropped by web transport, so you have to implement your own congestion control on top, and you kind of have almost like two algorithms, and you take the minimum of both of them. So if, for example, Chrome is using BBR for sending, and then you're using Cubic on top of that to avoid overwhelming the web transport API, you have a really low throughput. So it'd be great to get the low level, either some back pressure or expose some underlying state. And for the duplicate acts, I didn't realize this until we talked about it on GitHub. But because datagrams don't have flow control, there's definitely states where the quick packet could be act, yet the datagram was actually never delivered to the application. So I don't think you can use the underlying acts of the datagrams, unfortunately.
Thank you. That's a really good distinction, because I think the reliability side of that is definitely, like, if you had that signal, then you wouldn't have to build a second thing. But if there's a case where it can be act and not delivered, then you've got a problem. Thank you.
Yeah, I've run into this with data channels with WebRTC as well, with SCTP, where I just wanted to reuse the existing axe under the hood, but had to build my own on top of it, and it just caused double the packets, but it was unavoidable.
All right. Sorry, folks. I cut the queue after Alan, which I'm hoping that everyone heard because I wasn't sure. I might have muted at the time. Daniel, I see your video is on. If you want to speak, please join the queue using the hand raise thing. Oh, you're just saying hi. All right, cool. Sounds good. All right, then we're going to go on to Victor's next presentation, and let's try to keep the conversation or the comments a little bit shorter now because we are like running into our time and we really want to make decisions at the end of the meeting. So thanks, everyone. And Victor, you're up.
Okay, apparently I didn't configure the camera in advance, so sorry you can't see me. But I want to give an update on the one draft we've actually adopted. That's the web transport overview draft. So the goal is roughly to sum up what the requirements in web transport API are and what are the common properties and the semantics we expect from web transport protocols. Now, the specific, this, we adopted it, I presented it last time, and I think we adopted it even before the previous meeting, but there is one big update. Next slide. Yeah, it's just a reminder that like there is a GitHub repo and it has issues, and I'm not sure we might want to set up. I don't believe we have like an automated email to summarize all of the issues, but we should. But there is a GitHub repository for the repo, and it has some issues which I discussed at the previous meeting. But there is a new pull request that I wrote, and that's the request which relates to the idea of headers. Next slide. So out of proposed transports, the two transport already have headers. H2 transport and H3 transport naturally had HTTP headers, and we were just using those. So so quick transport first didn't have any headers, and we had some clever tricks to get away with not sending them that did not work. Then we added a very bespoke unidirectional header format called client indication, and that is what's currently in the Chrome implementation in the origin trial. And in the latest revision of the draft, which I still yet to upload because I also need to solve some issues with error handling, there are actual fully featured headers, which I tried to basically replicate the HTTP fields where there was an equivalent HTTP field, and there is, but it's the fields defined are origin, schema, authority, path, status, and the proposal is that since all of the proposed transports have those headers, we should define those headers as a shared property of any transport that's web transport. Just like having streams and having datagrams and having origin check is a shared property. And I wrote up a pull request, and everyone is welcome to review and comment it. And so that's basically all of the updates from the overview draft. Anyone has any questions or comments?
Well, thank you, Victor. That was incredibly fast. That really brought us back to the agenda time. Yeah. I'm getting reports from a bunch of people that MeetEcho is going through some serious technical issues. If you're trying to speak or join the queue and it's not working, please like say, oh, I was going to say so in the Jabber, but apparently the Meet Echo chat is busted as well. Go ahead, Lucas.
Yeah, so my hat's available for free on a Snapchat filter thing. I'll send links around later. But the serious point, Victor, just a question about this change. I just wonder if, depending on the direction of like whether people want quick transport or not, the rest of them, if this proposal is still like the thing you think is the best option. So it's going to be HTTP style, even if we don't use a HTTP style transport. I wondered if you could clarify, please.
I'm sorry, I kind of misheard the end of that question. Was that aimed at me or at someone else?
Victor.
Okay, that's what I thought. Victor?
Yeah.
It appears
no
that
longer-
Victor has dropped off the list.
Oh, yeah, and he's sending me messages on chat saying that he can't get into Meet Echo anymore.
It's okay.
Enjoy it while it lasts, people.
The issue.
Yes, thanks, Lucas. Please bring it to the list, or ideally even an issue, and we'll get that sorted. Yeah, that's not great. All right, I think we'll move on to Eric's presentation. So what I'm getting from folks is apparently, if you're in Meet Echo now and you can hear us, don't touch anything, it'll keep working, but if you refresh or anything, you won't be able to get back in. So, all right. Eric, if you want to join audio and video. Oh, I don't see Eric in the participant list anymore. Okay. Well, this is a mess.
Do you want me to talk to the H2 slides?
So that's an option. Yeah, because I was gonna say we could also do the next presentation and then come back, but if Victor's gone, then we can't do that. So yeah, let me let's do that, Alan. If you can do
yeah, I haven't practiced, but I'll try to keep it short.
Yeah. Cool, awesome, thanks. Eric was saying that it was pretty short, and then go ahead.
Okay, go ahead and roll to the next slide. Yeah, next one. Okay, so we'll just give what's been going on since the last IETF. There's some GitHub issues have been filed and a little bit of discussion. There's some outstanding PRs. And basically all of H2 transport is kind of in a holding pattern, waiting for the working group to move forward on what are we doing with HTTP in general, because H2 is definitely, sort of the last in the pecking order in terms of transport. So if we're not going to do HTTP at all, we're not going to do HTTP2. Next slide. Okay, so one of the issues in the draft was about, the original draft didn't mention unidirectional stream support, and a question about whether we want to sort of have streams that are half closed by specification, or just sort of have, bidirectional streams where, it's the one side just doesn't send. And I think next slide just talks about like the proposed PR in there is like basically adding a flag, kind of like Speedy had, which was like just starts one half in the half closed state. And this kind of maps to the way quick streams work more naturally. Next slide. There's an issue open about being able to open streams that are additional round trips for people who might need a refresher. So the H2 and H3 drafts, because they can multiplex multiple web transport sessions on the same connection, there's sort of one step where you're sending, you're opening a stream that's defining your session, and then you're opening additional streams that are kind of hanging off that session. And so there's just an open issue to discuss, like, is there a way to do that in one round trip? Can you can you send the new web transport streams referencing the connect stream before you've received acknowledgement from the other side that that the handshake's gonna succeed? There's sort of an interesting interaction with H3 here, because H3, the streams could also arrive out of order. In H2, they can't. So you could end up, the receiver can end up with an H3 stream. If we allowed this, the H3 draft, you could end up with a web transport stream that has no session established for it yet, if you were trying to do it in a single round trip. So I think this issue is still open. I don't think we have any proposed resolution for it yet. Next slide. Datagrams, there's still not a definition of what exactly the datagram support looks like in H2 transport. Again, we're not working on it hard because we're sort of waiting for a nod from the working group here. I think on the issue, I proposed a strawman H2 frame that we could use to transmit datagrams that would be perfectly serviceable. Next slide. Okay, yeah, I've covered all that. Next. Okay, I haven't read the slide yet, so give me a second. I mean, I think, and this will just maybe feed into the broader discussion about HTTP versus quick transport. So, you know, the HTTP transports, you know, have this feature where you can multiplex the sessions, right? Whereas quick transport doesn't have that feature. So if you want to have, you know, multiple, call them web transport sessions, with quick transport, you have to open multiple connections, each one sort of independent. And I hear people saying complexity around the H3 draft, and I'm trying to like put my finger on what is the complexity there. And one aspect of it is this sort of being able to pool or multiplex multiple sessions together. Obviously, H3 has some additional complexity. Some of it I think is trivial, and some of it I think, you know, like for example, you know, QPAC or headers is like non-trivial. So anyway, but the ability to traverse intermediaries using these session streams and multiplex together, I think, is one of the sort of key differentiators between the HTTP world and non-HTTP world. Next slide. I think that's it.
Point of order as chair. I have been informed by the IETF chair that the data tracker authentication VM completely fell over and they're going to reboot it. But it means that it's going to, at some point, it's going to kick everyone out of the meeting. It's going to take 2 minutes to reboot, and then you're all going to be able to join again. So I'm going to say, like, let's keep going, let's keep talking. But if you're kicked out, go make yourself a beverage and come back in a few minutes and we'll resume. Hopefully it'll be good. So, but otherwise, yeah, keep going, Alan. Let's do it.
Okay, I'll take questions if anybody wants to talk about H2, but I kind of recommend that we should move on to H3 and frame most of it in terms of where are we going transport-wise. I don't think arguing about the details of H2 is important right now.
The queue is open if anyone is still in here. Go ahead, Daniel. So you enable your microphone by clicking the unmute audio button.
Can you hear me now? No?
Yes.
Oh, okay, great. Yeah, I was just wondering, I'm sure I misunderstood, but I thought, okay, so quick transport has multiplex streaming. Is that not the case? Or I mean, that is definitely the case. I just didn't understand in terms of H2 and H3.
So quick transport allows you to have multiple streams on one connection, but it only allows you to specify a single web transport URI. Whereas H2 and H3 transports let you open multiple sessions within the same connection using different web transport URIs and directing subgroups of streams towards these different virtual sessions within the connection. I think that's, like I said, I think it's a key difference between the sort of two transport worlds, and I think it's also where some people, I think that's where some of the complexity that people point to H3 or H2 and say, oh, it's complex. I think that's where some of it's coming from.
Testing. Can anyone hear me? It sounds like we're somewhat back.
Yes.
Like audio's
Okay.
back.
Great. Yeah, well, this is not ideal.
So
Well, I mean, it's improving rapidly.
when everyone got kicked out, did you get an answer to your question, or would you like me to repeat?
I did. As soon as I heard URIs, I understood. We do not have. I see. I'm a transports person, so I'm like, what do you mean we don't have multiplexing? We multiplex the streams in Quick, but we do not have URIs. So that was the confusion.
Great.
Right. Eric Kinnear, since you were going to give this presentation and Alan ended up doing it, is there anything you want to add by any chance?
Yeah. Mostly just a thank you, Alan. Thank you, Alan. I don't think there's anything else major to add. I think you did a really nice job of covering a lot of this. In terms of other items in here, there's intermediary stuff. We talked a little bit about that. I think the main thing is just, can we leave the zoo and can we actually make a decision?
Thanks, Eric. Do we have any, and seriously, thanks, Alan, for stepping in. Eric and probably Meet Echo both owe Alan a beer. Daniel, you have another question?
Yes. What exactly does it mean, leave the transport zoo?
Oh, no worries. It was at a previous Webtrans session that we have all these transports that we're trying to figure out which ones we should build. And I think Victor called it the big transport zoo the first time. And so now the running joke is, let's get out of the zoo.
Okay, so when you figure out whether it's going to be H3 transport, H2 transport, TCP transport, UDP transport, or whichever set of that it's going to be, then we will be out of the transport suit.
Exactly. It's so the main question is saying which of these do we need, which of these should we build, and like in what order. And we're hoping we have some time at the end of the session tonight that we're hoping to really answer these questions.
Sounds
All right.
good. Thank you.
Of course, yeah, and I should have clarified that. My apologies. Any further questions on H2, or should we move on to H3? All right, let's move on. Is Victor back? Yes, I see Victor in the participant list. Victor, you want to re-enable audio? There you go. All right. Hear you, Victor. Your marked is not muted on MeetEcho, but I can't hear you.
Sorry, I had other layer of mute. Okay, so I'm going to give update on H3 quick, and then I'll give update on the transport zoo. So next slide. So just as a reminder, H3 transport is H2 transport, but that's over H3. It has the datagram support through Quick Datagram. And the specific mechanism for embedding datagram into H3 is described in draft schematic Quick H3 datagram. Their draft, we are currently converging it with design decisions and H2 transport. There is a pull request I wrote. Everyone is encouraged to take a look at it. It includes switching from using transport parameters to negotiate web transfer support to using an HTTP free setting, because that's more application layer and that just makes more sense. There is a redesign to use stream IDs as like identifier for web transfer sessions. That is also a design decisions that was in H2 and that made more sense, and that allowed me to delete 2 paragraphs of text from the spec, so that's nice. And that's basically it. I did some other minor adjustments, but everyone is welcome to take a look at the pull request for all of the details. Next slide. Quick transport. Quick transport actually got more update. I've not published a draft because there are still, I need to fix the story with error handling and error codes. But the basic idea of quick transport, if you're not familiar, it's quick, but it has a handshake in front of it. But after you're done with the handshake, you can treat your web transport connection as if it was just a regular quick socket. So it has ALPN values that's dedicated for it, and that's not HTTP, and that allows us to avoid cross-protocol attacks. It has its own dedicated URI scheme called quick transport, quick-transport : // and it has the same syntax as HTTP URLs. So as I mentioned before, we used to have a very bespoke header format. We have a new format that's bespoke, but now it used to have numbers as keys. Now it has strings as keys, and those follow roughly the same semantics as HTTP. And the reason I want this is one, having header names as strings instead of keys is greater for extensibility, because this lets people who are rolling their own things on top of this to add their own headers without having to fear any collision, because otherwise it'd have to work with numbers. And that's the main reason. It's still easy to parse. It's basically 16-bit length prefixed strings everywhere. And one of the main conceits of quick transport is that you get exactly one quick connection per your instance of your transport. That is suboptimal if you open a lot of web transport connections, because you do not get any pooling. And this also allows, on the other hand, allows you to do a lot of things like swapping in your custom congestion controller on the server side, etc. That you would not be able to as easily get away with if you are just using HTTP free and one connection for everything. Next slide. So this is an example of how quick transport URL scheme, if you do not remember, this says, I've not updated the slide, but all of the highlighted values are now sent completely in the handshake. So that's another update / improvement. Next slide. As a reminder that this draft is actually implemented in Chrome, there are instructions on how to do things with it. And I think already Bernard went earlier today, so I'm not going to go back into this. Now let's get to the Great Transport Zoo. I regret to inform everyone here that we've been approved for third season of this. The Great Transport Zoo is where we look at all of our transport and decide which ones we want and which ones we don't. And there are 4 options, which means that there are 2 to the power of 4 variants. And we're largely arguing for 3 or 4 of them, I think, at this point. But there are 3 aforementioned. There is a hypothetical fallback transport, which I think at this point no one seriously considers, because if you want to do that, it was idea that you could roll a transport on top of WebSocket, but you can do it completely yourself. So we don't need an IETF working group for this. Next slide. So as an overview, there are like very easy axes that you can split: dedicated versus pooled, quick versus TCP, and those are the kind of defining characteristic of those. Those used to be less defining. With last updates to quick transport, H3 transport, etc., I feel like they're most important in characteristics of all of those. Next slide. So here is, however, there has been some interesting details that happened on API layer. So one thing we did is we updated the API somewhere in September, and that's in the very latest versions of Chrome, where we noticed that there is a very silly redundancy. If you look at the old approach, you will notice that the choice of transport is indicated twice, once in the constructor name, once in the URL scheme. And of course, that's redundant, so we renamed the API entry point to Web Transport. And that had the very nice side effect of basically now, before that, in order to implement all of the transport, we would have to write code for all of those JavaScript classes, and that added a lot of cost. But now that this is entirely dispatched by URL, this moves the problem of actually taking the transport down to the network layer, which removes overhead from shipping multiple transports, or both on technical level, but also I feel on conceptual level. Martin, you.
Thanks, Victor, for noticing so quickly. I'm sorry about being so slow to jump in. Point of clarification there, when you have these two, say quick transport or HTTPS one, the fallback methods aren't necessarily done by the browser, are they, in the quick transport version? So they might be done in the HTTP version.
In the new quick transport, there is no automatic fallback because quick transport only exists over quick, and you basically get to do this manually. And in HTTP version, you have to delegate this to the browser because the browser is the only entity that knows the state of your socket pools. So if if it knows whether you have H2 or H3, that means it will find the appropriate socket and opens the session on that.
Yeah, I guess my point was that if you pick the new approach number 1, there's potentially a fallback involved that requires new API surface of some shape.
There is a potential for new API to add more control over what exactly happens. But the basic point I'm trying to make is that there is it's still much easier conceptually, because you can just, this is now just a knob you tweak instead of like completely different things that require completely different code paths.
Good. Thank you.
Thank you. Next slide. So just to clarify conceptually the difference, so this is the very first, this is how it looked before, and on the next slide you can see that thanks to this, there is one less box, and actually one less arrow is what's more important, because a lot of implementation expense here is crossing the sandbox boundary. Next slide. So so I've made repeatedly the observations that as we've refactored more and more both quick transport and H3 transport, they become more and more similar semantically. And at this point, there is some debate to this, but at this point, I am basically convinced that HTTP free transport exists primarily as quick transport with connection pooling. And that kind of makes sense, because if you think about it, there is no really substantial difference for them to be different entities. Next slide. So one of the ideas I had is we have quick transport and HTTP free transport, but we could, so currently we disambiguate them by scheme, but it is actually like, that's a choice made by client, and that makes them semantically different. But we can also even delegate the decision to the server by offering both HTTP free and web transport as ALPN. So if you just want quick transport, you just offer quick transport, and then it will offer both of those, and you get quick transport. And that is perfectly simple from the server perspective. And if you want HTTP free transport, if there is an existing socket and existing HTTP free connection in the socket pool that supports that, you will get HTTP free transport on that HTTP free connection. Alternatively, it will establish that connection anew to that server. And the reason I like this is that this allows us to make progress without making any assumption of what transport we're actually using. But I do believe that we still should make progress on that, because this is logical, but we still should actually decide which transport we're shipping. Next slide. Okay, so I have my observation here. So speaking of path forward, I am basically at this point convinced that the question is not like which one of those we want, but should we implement HTTP free transport, and is it worth it? And let me elaborate on that. Now that we've implemented, like once you implement the top layer, which is like the web API, and the middle layer, which is your the things that crosses your sandbox boundary and make sure that flow control, etc., is preserved. Now, there's a bottom layer, which is the protocol, which is the only part that's different between those two. But if you're implementing HTTP free transfer, the marginal cost of implementing quick transfer for both web browser and even the server, but web browser is the only one which really has to ship both, is fairly minimal. The Google implementation is 2,000 lines of C++, and that's not that much. That's at least 10 times less than our HTTP stack. That's approximately 5 times less than just the files that decode all of the quick frames. It is very little code comparatively, and those 2,000 lines includes the integration test and the unit test, obviously. And the reason I believe that quick transport is particularly appealing is that if you think of the other elements in the ecosystem as HTTP2 and HTTP3, quick transport is kind of HTTP 1 of web transport because it is the simplest thing that can work. And it is sufficient and optimal for a lot of cases. For instance, if you're doing video streaming and you have a dedicated server you connect to and you do not have any form of pooling that you care about, you will probably want to have quick transport, and that is what Luke mentioned, and this is also true, for instance, for YouTube. YouTube does not use HTTP2 for video serving. It always uses HTTP1 because HTTP2 is just a necessary overhead that it doesn't benefit from. So that's one example. And so the two main questions are, do we want to provide pooling and do we want to provide TCP fallback? Now, before we go in depth into those two and into discussion, I kind of want to give my perspective. My personal feeling about one is yes, so I will note that this is hard. And the reason is that as we've observed, every sufficiently advanced protocol eventually evolves into supporting pooling. HTTP does that. WebSocket does that, even though there are some obstacles to shipping that. So this is like an incremental step. Number two, the reason I believe TCP fallback would be good is not that it is of immediate use to everyone who uses web transport who would immediately adopt web transport right now, because if you're adopting web transport right now, you're probably someone who has a lot of resources to experiment, and you probably have an existing solution which works over TCP, so you would not want to replace that. Now, the reason, if you're building a solution from anew, I believe that web transport will be widespread much earlier than we will get rid of all UDP blocking, which is, I believe, we will probably never get rid of, because I do not see firewalls and enterprise policies ever going away. So I believe there will be demand for solutions that are architected from completely anew to support automatic fallback. And this is not something we might benefit immediately from the immediate users we've talked to, but this is definitely something that makes sense long term. That is my perspective, and I would now like to get into discussion.
All right. Thanks, Victor. Actually, maybe go back one slide, Bernat, that way we can still have the questions on the screen. So yes, folks, please join the queue now. And Alan, you're up first.
Okay, so I think the question I want to highlight is that pooling can mean two different things. One of them is I can pool multiple web transport URIs together in the same connection as I was talking about. The other one is, can I pool web transport on the same connection as my HTTP traffic? And they're kind of two separate questions, right? Quick transport, as it's currently defined, will never let you do the one where you can stick it on with your HTTP connection. You'll always need a second connection. And I think personally that there are, I want to speak to pooling web transport with HTTP together because it has some distinct advantages. So all of that traffic will end up sharing the same congestion controller. The streams on that connection can be prioritized with respect to each other. And there is some non-zero amount of server-side cost for having connections. So if I'm doing something in, as a client and I have an HTTP connection and then all of a sudden I want a web transport connection, I don't have to have two connections. I can just keep using the one that I already have. That's all.
Okay, Eric.
I like the framing that you've got here for how can we kind of unify this down into an API that is just I'm doing web transport and I'm not trying to pick up front. I think in a lot of other areas, we talk a lot about expressing the properties that we need from the transport and having it do the right thing in terms of providing you those properties. We saw, I think it was Bernard's table of the different use cases. You know, some of them said I need unidirectional, some of them said I need bidirectional, some of them said I need ordering, some of them said I need unordered. And there's a whole set of things that are perfectly fine if you don't have unordered or unreliable data, those being distinct items. Some of them are, you know, I am not willing to even consider having this conversation with whoever's on the other end if I can't have X thing that I believe is critical. And so I think having an API that we can use to express that spectrum of need from I'd really like this to I'm not even willing to show up to the table if I don't have it is potentially of value. I'm not totally sure that we can distill all of that down into just do we want pooling and is TCP fallback necessary? But I think if we can focus in on how does someone as a consumer of this API interact with what they need and how do they then use what they get back from it, we're probably going to be in good shape. Because some of the concerns around is somebody going to implement X versus Y seems a little bit like they have to do, you know, amount of work, something. And so it's not super clear to me that that trying to guess at what people are willing to support is as useful of a benchmark as the what properties do we get from these transports and which ones do we need and which ones can we do without.
Luke, I think you're next.
Hello again. So in regards to pooling connections, I do want to at least talk about what situations it would be useful, as in it would actually improve the experience for connection pooling. And in my mind, you share the congestion control calculations, which is great. But you kind of need to have two connections to the same host that max, you know, that both of them need to transfer a lot of data as well for that to even be a benefit. So you kind of have this case where you either have two, you know, web transport connections to the same host, and they're both using a lot of data, or you need to have an HTTP connection and a web transport connection, again, using a lot of data. Otherwise, Quick does a pretty good job of connection pooling. You can use the same socket, you know, 0 RTT if you wanted to make a new connection. I'm just failing to see the use case as which pooling is actually an improvement over dialing a new connection. So that's at least my feedback on there. And for number 2, TCP fallback, I think the problem is that the web transport API is the same for all the transports, but the functionality is not the same. As in, you might get that nice like pretending like we're using datagrams or pretending like we're using multiplex streams, but if you're actually under the hood, you have header-blind blocking because you're using TCP. There's no point. Like, I mean, it's nice. It encourages adoption if you can have the same API, but it would be something that, for example, I would explicitly try and disable. I would not want TCP because that would just ruin my application. I would need to disable that functionality for that fallback.
By the way, can someone hear me?
We can hear you.
Okay, because I've been doing queue management for a while, and I realized that no one was hearing me. So, grumph. Okay, so I had to reconnect audio, and we're back. All right, thanks a lot, Luke. Victor, you're in the queue, apparently?
Yeah, I had to. Yes, I wanted to say something. I have first regarding to Luke's remark. It is in fact the case that we do need to add a knob to API to express something like I only want quick, or I don't care if I get quick or TCP, or I want quick or TCP, but I want to know which one I'm using. And I do agree with that. Now, my remark is another aspect of HTTP I forgot that I realized long time ago is that HTTP is, due to metadata, is more amenable to intermediation. Namely, think about aspects like priority. You can, in HTTP, provides you with a way to communicate priorities of your individual streams, but that is not something you can do on raw quick, because raw quick has no way to communicate that kind of metadata, and all of that metadata is just an API call. That's an example of another consideration that I think that was mentioned sometime long ago, but I forgot. Anyway, that's my remark.
Martin?
It takes a little while to come through. So Victor's point there about priority is an interesting one, but I don't think it's particularly relevant here, because you're not going to be able to use the HTTP level signaling to get priority signals back and forth. And Quick has priority, or any Quick implementation should have priority anyway. And it's just a question of how you're signaling it. I was going to get back to the intermediation question, though, because Alan made a couple of points about mixing these in with HTTP. And I wanted to ask Alan, who, when he gets to his point in the queue, can answer, what specific benefits are you looking to have? Because my experience with at least WebSockets has been that they tend to be terminated by different machines that deal with different sort of services. And how do you imagine the relationship between the HTTP that's going on the same connection and the Quick the web transport streams that are going on the same connection to be such that you're gaining benefits from that? I can see how you might benefit from a congestion controller being aware of the current path state, but I can't see very many ways in which the co-hosting of the same two things can be of benefit. And there's the other thing was Victor pointed out the intermediation point, and I think it's a really important one. We saw with web transport that not a lot of intermediation goes on because there's no application level semantics being expressed in these protocols. There's no generic functionality that an intermediary can hook into to provide value. So they tend to be just dumb connections back to back-end servers with no value add by an intermediary, no extra load balancing capabilities, what have you. So I am sort of strongly now leaning toward the non-pooled case, in fact, but I'm very much still of the view that only one is necessary of the Quick options.
Makes sense. Daniel? You're muted.
unmuted. I'll be brief because this has been touched on twice already in the queue. I was just going to say that, you know, as far as the API goes, you absolutely have to be able to inform the caller of what the heck we did. Like, I can't just, if they ask for quick, I can't just switch to TCP. They have to know. I mean, the principle of least surprise. Am I still, hello? My screen just went. Still hearing you? Oh, okay. Yeah, that's all I wanted to say. So I wanted to not only second the idea of informing the user through the API, but also say that very emphatically in support of it. Thank you.
Cheers. Thanks. Ecker?
So with regard to both these points, I think I agree with Martin that like there should be one quick transport. I've gone back and forth a fair bit about whether it should be H3 or quick. I sort of read Victor's note to mail list about how quick was growing more like H3 kind of confused me, frankly, because it seemed like maybe they were the same thing. So I mean, I guess I am also trying to figure out what pooling means and not seeing a huge amount of benefit there. I'm not sure that, but I'm not sure that actually dictates the question of which quick-based transport we should have. You know, I think it's really quite disappointing that we're going to end up apparently with MASC being based on HTTP plus datagrams and maybe web transport based on some other thing. That seems like kind of like really the IETF should be able to figure out, like, if you want to push raw datagrams over quick to HTTP servers, whether you should do that with what kind of transport that should look like. Seems like really something I want to be able to do. And I remember, as I recall at the time, when MASC and in fact Rift were proposed, there was a bunch of discussion about how it ought to be in principle possible to implement them entirely in JavaScript using facilities offered by the browser, but that obviously will not be the case if MASC is specified on HTTP and Webtrans specifies quick transport. So I do think like there should be only one, but like the scope of there should be only one probably like is like somewhat wider than this working group. On the topic of TCP fallback, I certainly agree with what I've heard said a number of times, which we need to notify people. There's some knob of some kind to let people control/notify whether they have TCP or not. I do think some kind of TCP fallback is necessary. All the data shows that you don't reliably get UDP transport through like a large number of connections, and many of those connections, although they have inferior performance if they have TCP, still can do acceptable performance of various things over TCP, and so you know. If you want people to switch, if you think part of the problem with, you know, as I think people do with WebSockets is the API stank, and you like people to have one API, then forced them to switch it between WebSockets and web transport when they really want is just like a datagram abstraction that kind of works, seems like really kind of a bad choice. So I do think we need TCP, and I think we need to either turn it off or be sad if you got it.
Thanks, Edgar. Eric Kinnear, I saw that you were at the top of the queue and you're not at the bottom. Like, was that a mistake or did you intentionally go down?
I removed one comment and added a different one, so let's keep going and we'll come back.
Cool, sounds good. Alan.
So to address Martin's question, so I mean, I think one of the primary drivers is scale. So, you know, so I work at Facebook, and basically every phone in the world has a connection to Facebook. That's probably an exaggeration, but there's lots of them. And we do HTTP stuff, right? There's lots of reasons why there should be an HTTP connection from every app. But then there are also non-HTTP use cases that are going to go to the same place, particularly sort of more publish-subscribe based models, or notification, real-time things. There's obviously ways to kind of kludge that with HTTP, but we get a lot of asks from people who are trying to develop these abstractions. And so now we're faced with, okay, well, we're going to have one HTTP connection from every phone, and now we're also going to have a web transport connection. Or if we don't have any ability to pool multiple web transport URIs into the same connection, we're going to have one web transport connection for potentially every user of web transport, which is just not really going to work. You know, these things all end up getting terminated at one place. And in terms of what intermediation or a proxy can do there, it's not doing very much, but it is routing, right? So you might have, some uses on the phone which are being terminated in edge pop, and those web transport use cases are being routed to a data center where that service is running, but other web transport UIs are being routed to other data centers off the same connection to the POP. So, and in terms of, okay, well, you guys have your own app. Why don't you just write your own extension? And why are you bothering the IETF with this use case, which maybe is only specific for you? There's more and more push to use native stacks. And so we're a little bit out of the web context of web transport, but since we're talking about a protocol here, we, for example, like we would love, there are lightweight apps that would like to not use our HTTP stack, but want to use the native stack, or they want to use a thinner stack than the one that we've developed. And it's very challenging if there's not a standard way to do this kind of thing over an HTTP connection to get that implementation happening in other contexts. And there's also, then we have the same thing of all those products that run in apps also are going to run on the web. And the web developers don't want to, or the people who are developing that code don't want to know, like, oh, I have to write it one way in the app, but then I have a totally different protocol or way I handle things when I'm running in a browser context. Okay, so that's kind of a long-winded answer, but I think I covered it.
Jonna.
Thank you. Can you see me?
I can hear you. You've pressed the camera button, but I'm seeing like a red thing where it's failing to come through. But at least we can hear you.
But as long as you can hear me, yeah.
Mm-hmm.
So Alan's making me think about this. But so I came up to say, I'll say what I came up to say, and I'll also say what Alan's making me think about. So some others have also noted this on the Jabber chat, but I just wanted to gently draw attention to the fact that this, I fear that this might be trying to do too many things at the same time. And in doing that, it does seem a little bit like taps. And that scares me, partly because that's when something's not driven very strongly by one application, that tends to have a flavor of trying to satisfy a lot of requirements. So with that, I'll ask I want to ask the question of how many of these are actually use cases that are currently in play. Like how many people want to use which particular use case is the question I would ask. Now, I came up to say this sounds like if we wanted to be an evolution of WebSockets, then quick transport seems like a good step forward with a backup as something like WebSockets. It would be easier to see this as an evolution in that sense. But and therefore, I would answer the questions that you have there as, well, maybe pulling connections is not that much worth it. And TCP fallback, I would say in general, you definitely want TCP fallback if you want whatever API you are using to basically work all the time, because we can't assume that Quick will work all the time. But yeah, Alan has made a good point that there are cases, and in fact, he's strongly suggesting that it might be necessary to pool connections. In which case, then I would ask, is quick transport necessary? Should we just go to HTTP3 transport?
Thanks, Jonna. Bernard?
John?
Yeah, go ahead.
Jana asked some question, and I'm trying to remember what was the very question at the beginning. Oh, the question was, are there use cases that are for each of those? And my answer is, I believe that for each of the proposed transports, there is at least one person who is like actively interested in it existing, which is why those web transports, why we defined all of those in first place. But that's my answer. Anyway, Bernard.
Okay. Yeah, I wanted to follow up on what Alan said because I'm hearing some of the same things, that there is a desire to pool HTTP with web transport, and and not just web transports with each other, but pooling them together. Some of the scenarios I've heard, if you think about it, it's both for the scalability, which Alan mentioned, also the traversal issues, just to have everything go over the same connection, but also because I think there's a desire to significantly extend the web so that you have not just request responses that are reliable, but can also get datagrams coming back. Now, so in some ways, what they're looking for is an entirely new web ecosystem that supports datagrams kind of natively naturally as part of the web. It is a big ask because you want all of this, you want web transport to work with HTTP3, to work with MASC, so it's kind of like an entirely new ecosystem, so it's a very big bet. And there are many, many ways in which that bet could fail if pieces of it don't work together. But that's kind of what I hear is that there's they would see that if you could make everything work and get the pooling of both, that would be the biggest win. It's also probably the hardest thing to actually make work, which is the tricky part, because when I've gotten into trying to figure out what would be needed to do it, it does seem like there are a lot of moving parts. But it is a big win if you can make it all work.
Eric Kinnear?
Yeah, I would second a lot of what I think Ecker was saying, which is that I think it is very important that we end up with just one thing. But I think if we want to be able to deploy this stuff everywhere, we're going to need something for the cases where Quick isn't getting through. And we know we have that for web pages that are using HTTP, because we can fall back to H1 and H2. But we haven't defined what you do for the rest of the things that use Quick as a transport without HTTP. And I was really excited when we were doing Quick and separating out the kind of multiplexed streaming side of things from the HTTP semantic side of things. But I think either we need to hop on the HTTP bandwagon and use that to go across everything, or, and I say this not particularly caring what we end up with as long as we meet those needs, or we go with some of the kind of fallback transport style thing, which I think Victor had in the other section of that grid of options. But I think we need some way, both for web transport and potentially even just in the rest of Quick and the other use cases for Quick, to be able to have that fallback. Either it seems like we end up pushing everything that needs that fallback up to H3 and then kind of going sideways to H2, or we need to define something that allows us to do that kind of uni-bidirectional stream multiplexing over something that does traverse the corners of the internet where Quick doesn't. And we can do that without HTTP, and that would be great. But it does seem as though some sort of a fallback is necessary.
Thanks, Eric. So to try to get us to converge a little bit here, and I'm, I guess, speaking as chair, trying to formulate the consensus that's emerging, but please feel free to speak up if you think I'm getting it wrong. I'm getting a sense from the room that most of the folks who have spoken up agree that at least if we look at the Quick-based transport, so Quick transport and HTTP3 transport, I think we have consensus that we only need one of the two. Is the main sense I'm getting from most people in the room. Then if that's the case and we need to pick one, let's tease apart what are the pros and cons of each. And the main ones I'm seeing, and please jump into the queue to add more, is H3 transport allows pooling. So what that means is if Sorry, what?
Just a point of order. Maybe we could get consensus on that point you just made about there can be only one, and then we can move on from there, because I think we have consensus about that.
Yeah, actually, that's a very good idea. Thanks, Ecker. Let's
before that.
Yeah. Bernard, does that sound good? To try to do a hum about of specifically quick transport and HTTP3 transport, if people agree that there should only be one? You're muted, Bernard. I'm going to assume yes. So we tested out this virtual hum tool at the beginning of the session, and it seemed to work. So let me type in the question.
Victor says he has a question before the hum.
Speak up, Victor.
I wanted to ask specifically Ecker and Martin, since they repeated this point, why do you believe that there should be only one?
Okay, Martin or Ecker, if one of you two wants to speak up about this.
I would have thought the burden of proof is on people asking for two. I want fewer things, and I don't necessarily see that we need the complexity until the complexity is justified. I haven't seen any real justification for the complexity.
Thanks. Yeah, no, that makes sense. Like at the end of the day, our job as writing IETF protocols is generally not to make the biggest buffet available, is to try to find one thing that works. So I think I'm, from a personal level, not as chair, really in agreement with Martin on that one.
David,
yes?
if you don't mind, Jenna Iyengar here. I think that there's been a parallel conversation going on the Slack chat channel, and you might want to hear out what Philip has to offer. He's been in the queue, just because it might help people make up their minds. The idea here is to offer an alternative way of doing pooling without having to do HTTP3. This would be mask and quick transport. But I'm just suggesting that before you ask the question, it might be helpful for people to consider that as well.
Okay, Philip, if you want to jump in and make your case, go ahead.
Hi. So when we had the discussion about whether we want pooling or not, I came up with the idea that we can implement part of the pooling just by adding mask beneath web transports. So with this, you don't have to care about another layer of hole punching or session setup, because you can just reuse the HTTP3 session you used, and then piggyback on this session with mask all the web transport streams you need within a pool. You could also try to add some kind of prioritization of fate sharing within this. And so you could get away with pooling at this layer and still having the simple quick transport semantics beneath. Also this, if you have a multiplexed use case where you have a load balancer, only this load balancer needs to talk HTTP3, and you can get the much easier quick transport at the backend systems. So this would be a compromise of both designs without having to define both protocols at the web transport level.
Thanks, Philip. So to add to the context, as someone who is enthusiastic about mask, so that would definitely work. It would involve double encryption for quick, and on top of that, it would also require browsers to implement mask, which, well, I'm okay with, but I'm not sure if everyone is. But that's definitely an alternate view as well. But thanks. We're 10 minutes to time, so I'm going to switch now to the hum. So and of course, because I switched away, I forgot what I typed. Thank you. But so here's the question. The tool is going to say, do you want to raise your hand or not? And so if you raise your hand, it means there should only be one. If you do not, it means you think we should do both. So, all right, I clicked the button. So if you believe we should only do one of quick transport and street transport, click raise your hand now. If you think we should do both, click do not raise your hand.
Do not raise your hand. Yeah, click do not raise your hand. Well done.
disappeared before I got to click it.
Oh, so, God,
Too soon?
sorry, I messed up. I pressed the button again. Let me restart it. I apologize, people.
Nice, thank you.
All right. Yeah, the button from the chair's perspective looks like a confirm your choice when it means just stop everyone else from voting, which is really not what I was trying to do. Apologies, everyone. All right, let's all let it sit for a bit.
But I think the intention actually was to ask 2 questions if you want to have one or the other.
No, right now the question is, if you think we should only have one, raise your hand. If you think we should do both, do not raise your hand.
What I'm saying is, if you think we should do both, should be a separate question or a separate show hands or whatever. That was the intention, but it's fine.
I'm not sure I understand, Maria, but maybe we can take it offline.
Because you could ask both the questions and then you could just say, people could just not raise their hand for any question indicating that they don't care or whatever. That's why you should ask 2 separate questions. But anyway.
I see. That sounds like it would take longer, though.
But normal hums are
by not doing anything.
Yeah. All right. I'm going to end it now in the next 10 seconds. If you haven't voted, go right ahead. All right. So then, I guess I'm not so. I see the numbers. I don't know if everyone else does. I don't know if I'm supposed to share them in the spirit of the hums.
You can see them.
You can see them. All right. Well then, so it was 19. 19 raised your hand and 10 do not raise your hand. So that's a 2/3, 1/3. So not a clear absolute consensus, that's for sure. Victor, you want to say something?
Yeah, I actually had a proposal that I believe with which I want to believe which would allow us to move ahead. And I want to first reply to my ideas of why I did not raise my hand. And if you don't mind, can I?
Sure, but make it quick because we have 5 minutes left.
So my basic logic is that the argument for is that there are web developers who have different opinions on the pooling/complexity trade-off, and argument against are we should not define too many things, and that's too many things to implement for browser. And the reason I'm leaning towards the argument for is that I personally, and I'm not sure if there are IETF documents, but I personally tend to favor problems of web developers against concerns of browser implementers or theoretical POC. Now, my specific proposal is that we adopt quick transport as a starting point because it sounds that it satisfies at least some use cases for everyone. But we do not preclude adoption of HTTP transport in case we decide that the working group, in case there is a practical experience that shows it's beneficial and the working group has resources to ship that draft. That way, it's kind of we are learning to walk before we're learning to run. That is my opinion.
Ecker, do you have is that a response specific to this?
However the chairs want.
Or I'm asking, are you going to respond directly to what Victor is saying or do something else?
Yes, I was.
Go ahead.
Okay. Yeah, I guess I would not be in favor of that proposal because that seems to bake in quick transport and then have a high probability we'll end up doing both. So I think we are getting close to having the information we need to make a decision, and if we're not, we should deduce that information and make a decision rather than decide on one with then maybe we'll adopt the other later.
So thanks, Ecker. So I'm thinking. So it sounds like there's a majority of folks who would prefer to only do one. And one of the interesting things here is that we're not time bound. So my gut tells me that maybe we should pick one to start, only adopt one of the two for now, and we can always adopt a second one down the road. that sounds like something where I am, yes, effectively kicking the can down the road, but at least it allows us to pick one for now and to focus on one for now, so we can actually like get going and adopt one and like start, interop testing, as opposed to only having Chrome implement this. Do folks have thoughts on this proposal? And I'm realizing we're getting really short on time, so please keep your comments as short as possible. Alan, go ahead.
Okay, I think I just want to second what Ecker said, which is that if we're adopting quick transport now, and it just creates a high bar to adopt H3 when it sounds like there is more consensus about which direction we're going. I mean, I really view H3 as a superset of what quick transport can do, and you don't have to use the features that you're not using or that you don't want to. So I just don't think that adopting quick transport right now is what I'd be in favor of.
Okay, thanks, Alan. Kinnear?
That I think there's a risk here. I don't necessarily care as much about which one we pick, although I think we do have a set of needs that we need to fulfill. But I think going with one and then telling ourselves that we're maybe going to go with the other, it would be really unfortunate if we ended up in a place where we're trying to get the earliest implementers of everybody to actually interop, and we find out that half of people do one and half of people ended up having to do the other because they needed something that wasn't available in the first one.
Okay. All right. Ecker, are you back in the queue? If yes, please, 30 seconds, because we're almost at time. And then I'm cutting the queue.
So yeah, I mean, I think I'm happy for us to choose one, but I think we should choose one on the basis that that's the one we want. And then, yes, we could always add one later, but I think we shouldn't choose one with the theory that we're like just getting experience. We should choose the one we think is the right one. So I guess I'm saying, like, I don't think we should shortcut that discussion. I think we should try to decide it.
Oh, no, absolutely. And I wasn't proposing to pick anyone in particular. I was saying that we should pick one. And but clearly we're not going to pick one in the room today because we're out of time. The AV issues did really hurt our flow here, which is unfortunate. So we're at time on the session. We did not come to a resolution on getting out of the transport zoo. I sincerely apologize as chair for that. But we will do better. I'm thinking that we need to accelerate this because having progress happen every 4 months at IETF is not good enough. So I'm thinking that an interim might be a good idea here in the near future, so we can try to hash out, so like maybe get all this discussion happening on the list and then have another like interim meeting sometime in the not too distant future to really try to drive this home. I would really love us to like get to a point where we can pick some number of the protocols to adopt them in the working group, so we can actually move from zoo visiting to protocol design. On that note, we are exactly at time. Thanks to all our presenters and to everyone who took the time to attend, especially folks who are in unpleasant time zones. So thanks, everyone. And Bernard, do you have any closing statements?
No, just we will set up the interim scheduling requests and get going.
All right. Thanks, everyone, and enjoy the rest of your day or night. Cheers.
Yeah.
Take care, everybody, and remember, nobody escapes from the transport zoo that easily.
Thanks. We'll get out of there someday. We will. I promise you that.
Keep the faith. Thanks, guys.
Cheers.
All right.